Welcome to Calculus. Being challenged has a whole new meaning. On this episode, Stevenson will demonstrate Now that we've seen some other examples of chain rule, we might be feeling, okay, I think I got this, a little confident here. I have some more examples where chain rule can become a little more complicated. Let's look at number 13. Notice, not only do I have a negative exponent, but I have a radical. So again, we're still going to approach it exactly how we've been doing. We need to know what's the outer function, our f of x, and what's our inner function, our g of x. How'd you do here? Notice a couple of things. Number one, my outer function is something to the power of -2, so I apply power rule here. Number two, my inside function, notice I rewrote the radical as x to the power of 1/2. Why would I want to do that? Well, now I can do power rule. And remember, power rule is multiply the power by the coefficient and then reduce the power by 1. Now I'm ready to actually apply my chain rule. I would stop here. I wouldn't take the time to simplify this down if it's a free response for sure, and if it's multiple choice, I would look at my options. As with any derivative, our derivatives can be taken multiple times. What? What do you mean by that? You can actually do a repeated chain rule within a problem. That means there's more than one chain. Let's start by figuring out what is my outside and inside function. I'm going to stop here. Hopefully up to this point you can see what I did. But when I go to do g prime here, do you notice the derivative of 1, that's easy, it says 0. But wait a minute, cosine of 2x, that is another chain. So let me show you a way you can handle this. You can introduce a new outside-inside function, and I highly recommend don't use f and g again, use two new variables. I'm going to let h represent my outside function, so in this case I can see it's cosine of something. And k will be my inside function. Now, in order to actually put this all back together, I worked my way from outside all the way in. Now I'm going to piece these back together, but I have to start with their innermost function first. So remember chain rule, it's still the derivative of the outside with the inside left alone times the derivative of the inside. Now you may be wondering, why did I rewrite this? I prefer to rewrite any constants up in front as coefficients. It makes it a little bit cleaner. Now what did we just figure out? Well, let's follow our work backwards and we realize we just figured out g prime. Now remember, g prime is the larger piece of the original chain rule. So now we can apply this g prime to the original chain rule problem. So the derivative of the outside with the inside left alone times the derivative of the inside. This one doesn't have a very difficult rewrite, so I'm going to go ahead and do that. I have a 2 and a -2 as coefficients. I'm going to rewrite them in front. So this is what I would call a double chain. Why? Because you have to do chain rule 1, 2 times. How about one more practice problem here? This is another chain rule. I can hopefully see that the outside function is going to be this radical function and my inside is a tangent of 5x. But hopefully you're starting to recognize that tangent of 5x, that itself is also a composition of the tangent function and the linear 5x. So let's apply our chain rule. Again, the first thing we want to do is figure out what's our outside, what's our inside. So, did you get this far? Hopefully you did. Now, when you recognize when you go to do g prime, tangent of 5x is another chain. So again, I'm going to introduce two different variables to represent my new outside and inside function. Now that we have all the pieces, let's reassemble. Remember, the derivative of the outside with the inside left alone times the derivative of the inside. I technically don't have to do that, but remember, I'm gonna have to take this G prime and reassemble it into my first chain, so it'll make it a little bit easier, especially if it's a multiple choice problem. Now that I have this G prime, now I'm ready to go back to my original chain. So it's f prime of G, or the derivative of the outside with the inside left alone, times the derivative of the inside. Now in this case, I can see I have a half coefficient here and a 5. I'm going to go ahead and rewrite those in front.